Alright, so in this video we're going to cover the discriminant, and this is a graphic organizer I was going to give you guys on Monday. So I'm shooting this video after school on Friday right now, and the idea is really with the discriminant, the way we want to use it is to be able to tell how many solutions an equation will have, and whether or not there'll be real solutions, and if they're going to be imaginary, what's going to happen, right? So you can see in this graphic organizer right here, it's telling you that if the discriminant is positive, right, if we calculate b squared minus 4ac and we get a value greater than 0, that it's going to have two solutions. And that would mean that our parabola, if we were to graph it, that we would have two x-intercepts, right? And in the case that the discriminant is equal to 0, we will have one x-intercept, right? We'd have one value that would make it equal to 0, yeah? Okay, in this case, it'd be the vertex that's right on the x-axis. But this graphic organizer is kind of not totally correct, right? Because we're talking about real solutions. So it says that there's no solutions, but this is actually not correct by the way that we're talking about, okay? Today we learned that when our discriminant is negative, right, when it's less than 0, then we're going to have two imaginary solutions. So depending on who you ask, depending if you're actually dealing with complex numbers or imaginary numbers, you're going to have a different value, right? But this is basically the idea that you want to do when we're using the discriminant, right? You want to try to calculate it, and if it's greater than 0, then you know you have two solutions. If it's equal to 0, then you have one solution. And if it is, let's go ahead and white out their idea, because they did some good work here on this graphic organizer, but unfortunately this last part is not totally correct by the way we're looking at it here. Alright, at school today we learned that if the discriminant is negative, we would have two imaginary solutions. Okay? And in this case, that would mean that we have no x-intercept still though, right? Because in this case, we have a graph that doesn't actually cross the x-axis. So what I want to do to try to make some sense out of this, instead of just having you guys become math zombies like I was saying to my 6th period today, I want us to understand what's going on here. So let's go back to an old assignment that we did a while ago, where I had an argument with the worksheet generator, right? We saw that these two examples were not factorable, right? Not factorable with real numbers, right? They didn't have any x-intercepts. But when we got to this one, to number 32, we saw that they did have x-intercepts, right? So if we were to go look at this right now, we can use the discriminant to help us figure out what's going on here, because this was a problem when we were factoring things, right? I didn't want you guys to start to do a problem that wasn't possible, right? Imagine how much time you could waste on that, right? And so this is one thing that the discriminant can do, is you can calculate that, and it'll help you figure out whether or not this thing is going to be factorable with real numbers or not, right? Sometimes we want to count those, complex solutions. Other times we don't care about them, right? Maybe if we're doing something with like projectile motion or something, we wouldn't care about those, right? So let's go to Desmos. And what I'm going to do is take a look at number 32, this equation that we have right here, 3x squared minus 10x minus 10. And we're going to go see why this actually is factorable and why it would have solutions. And if we go through this whole problem, we'll understand a little bit more about how the discriminant can help us figure out what's going on, right? So we could also look at 28 and 30 and see the difference between these two, right? In fact, let's do that first. Let's look at these ones and we'll see the difference between 28, between 30, and 32. And we're just going to look at the graph really quick, right? So let me jot these down and we'll go plug them into Desmos and see what happens. Okay, so here we are in Desmos. I'm going to go ahead and graph the first one that said that it was not factorable, and we're going to see what did that really mean, okay? So I'm going to type in f of x equals 5x squared minus 2x plus 20. And if we take a look at this, right, we can see that in standard form, the y-intercept would be 20. And we can see that, you know, as I zoom in, like, we still can't even see the function. It's so high up there. And so let's zoom out so we get a better look at the graph. So you can see right now, maybe I can make that a little more bold so you can see it. Okay, so look, this graph would not be factorable with real numbers because it doesn't have an x-intercept, right? So there's an important theorem that we're going to learn pretty soon about the fundamental theorem of algebra. And basically, every quadratic polynomial can be factored, but just not always with real numbers, okay? And if it can be factored with real numbers, then that means that it has x-intercepts. And since this one does not have x-intercepts, it can't be factored with real numbers, okay? So we would probably solve this either by completing the square, or we would just use the quadratic formula to figure out what those factors would be. So you can see right now that if I were to calculate the discriminant of this function, right, we would get a negative discriminant. So I could even pull out the whiteboard format right here, and we could just work with this background. Keep this in mind, all right? Our discriminant is b squared minus 4ac. So if I was to figure out what a, b, and c are from this equation right here, we have a is equal to 5. We have that b is equal to -2, and c is equal to 20. So if we go plug these numbers in, we're going to start to connect these ideas with graphing so that we can have a sense of what's going on, right? I think graphing is really concrete, and when we're just using numbers, it's hard to see what's happening. So we plug in the -2 for that, we plug in the 5 for A and the 20 for C. We could do this calculation, and we can see that -2 squared is equal to 4, and we would have to do 4 times 5 is 20, and 20 times 20 is 400, right? And what is it that I did incorrectly here? Oh, well, nothing, right? Because we have a negative value, like I said we would, right? So we'd have -396. And because this is less than 0, that means that our discriminant is less than 0, right? And so because of that, we can see that that means that we would have no real solutions, and instead we would have 2 imaginary solutions. And so we can kind of understand that the numbers are helping us see, before we even look at the graph, before we take the time to go graph it, we can already see that it's not going to have x-intercepts by just doing this calculation, by doing the discriminant, plugging in those values and getting a -396. That tells us that we're not going to have any x-intercepts, and that's why this graph will be above the x-axis, and it'll be positive, right? So we can see it's just not going to have any real solutions. So we could do another example, right? Like I said, we'll do that second one from that worksheet on factoring, number 30. We'll look at this one right now in Desmos, and we'll go see what happens here. So in this case, we have 5x squared minus 3x plus 3. And we can see that this one also does not cross the x-axis. So if I was to calculate this discriminant, we would see that this one also is going to give us a negative value, right? Again, our A in this case would be 5 again, but now B is going to be -3, and C is +3. So if I go calculate b squared minus 4ac, okay, and do all the steps that I need to, change all of these for blank parentheses, we could plug a -3 into this spot, a 5 here, and a 3 right there. -3 squared is +9. And like I always tell you guys, to leave an extra blank parentheses to help us remember all the double negatives. So 4 times 5 is 20, and 20 times 3 is 60. So we can see that 9 minus 60 is definitely going to be negative, right? We'd have -51, and that's less than 0, right? And so in this case, again, our discriminant is negative, and that tells us that we would have 2 imaginary solutions. And as we can see from this graph, we'll have no real solutions, okay? And by solutions, we would mean solutions to the equation 5x squared minus 3x plus 3 equals 0. this equation will have no real solutions, right? It's not going to actually ever be equal to 0 for any real numbers. We'd have to use imaginary numbers to make that equal to 0. So let's go take a look at why I think, looking at this with a few of my classes, and I was trying to show them the discriminant to be able to find out the ones that were impossible, because, you know, we thought to ourselves, wait a minute, if I'm going to factor expressions like this, and every now and then they're going to be impossible, how are you supposed to know whether or not they're possible, right? And, you know, I tried to explain, well, technically they're always possible, but just not always with real numbers. So let's go look at number 32, which is one that I had kind of a problem with, because I thought this one was actually, this was incorrect for the worksheet generator to tell us that it was not factorable, because it is factorable. It's just not factorable with integers, or even with a rational, with whole numbers in this case. I think we can see that this graph, I just graphed it, 3x squared minus 10x minus 10. Look, it crosses the x-axis at these two values. So what's going on, right? This thing says that it's not factorable, but it has intercepts, and so it should be equal to 0 somewhere, and that means that we could be able to factor it. So let's use the discriminant first of all to see why we should know that it does have two real solutions. And then we'll try to track down what's going on with this whole factoring, right? So we mean that if we were to look at the equation 3x squared minus 10x minus 10 equals 0, this does have solutions, okay? And to be able to tell them without plugging in the whole formula, we could do the calculation of just figuring out what the discriminant is, right? And the discriminant in this case, let's figure out our A, B, and C, right? A is equal to 3, B is equal to negative 10, and C is also equal to negative 10. So let's go ahead and plug in our values for B, for A, and for C. B is going to be negative 10, A is 3, and C is negative 10. And so negative 10 squared is equal to positive 100. And then don't forget your blank parentheses. And this is going to help us in this case to figure out that we're going to have a double negative, right? Because 4 times 3 is 12, and 12 times negative 10 makes negative 120. So look, we have a double negative, right? We have 100 minus negative 120, which really means 100 plus 120, right? Let me fix that. And so 100 plus 120, that gives me a number that's positive, right? That's definitely positive. We get 220. That's bigger than 0. And so our discriminant is bigger than 0. And so based on our work that we've been doing lately, we would see that this means this definitely has two real solutions. Okay? But this is not necessarily going to be a rational solution right now, because we have a square root of 220 that we'd have to take, right? And so is that going to be a rational value when we take the square root of 220? Well, we could go look at that, right? So let's make like a new page and realize when I do this part of the quadratic formula, I would end up with 220. So this is going to be a rational solution if I can write the square root of 220 as a rational value. So let's go see what I get if I take the square root of 220. Well, the square root of 220, we'll try to break that down as, well, that's, right, 10 times 22. Just think of it like that, and then we'll just keep breaking it down. 10 is 2 times 5, and then 22 is 2 times 11. And so we can see already here we have a problem, right? There's a 2 and a 2. So that's a repeated factor, so we could pull out the 2. But we're going to have the 5 and the 11 stuck in there, and so we'll have a square root of 55 there. And so we can see this is an irrational value. This is an irreducible fraction, right? We can't break this down. I'm sorry, irreducible square root. We can't break that down. So that means that now we're going to end up with an irrational solution, but it is real, okay? This is a real number. It's not imaginary, right? So we would have two irrational solutions in this case. And for whatever reason, the worksheet generator decided to tell us that this problem was not factorable, but it is factorable. The factors are just going to look really weird, okay? So we can factor it if we wanted to, but the factors would be very complicated and they would have some square roots involved in them, right? So it wouldn't be something that we could necessarily do as quickly as the ones that are done by integers, right? So, you know, I was trying to explain why we would need the discriminant, what would it help us do? And in this case, we could see that it would show us that these two graphs will not cross the x-axis, but the discriminant will also show us that this one would cross the x-axis. And we could figure out when it would cross the x-axis if we would just solve using the quadratic formula, right? So I could make a page right now and we could go solve this equation using the quadratic formula to try to verify a little more of what happened here. So if we had that equation 3x squared minus 10x minus 10 equals 0, we apply the formula, right? X equals negative b plus or minus square root b squared minus 4ac. And like I said, I'm trying to stop you guys from just becoming math zombies here and just doing a bunch of calculations without knowing why we're doing them. So let's go plug in our values for a, b, and c, right? We can see that a would be equal to 3, b would be equal to negative 10, and c would be equal to negative 10 also. So let's be careful with our negatives. We'll put in a negative 10 right here. We plug in a negative 10 for b, plug in a 3 for a, and a negative 10 also for c, and a 3 for a. Okay, so now we're simplifying through, and we see that that's going to give us 10 plus or minus square root of 100 minus, and then give me a big blank parentheses to go there. It's all going to be divided by 6 at the end. And now we have this number that's going to be, like we said earlier, negative 120. When I do 4 times 3 times negative 10. So in this next step, we're going to express just the idea of changing the sign of that double negative, and then we'll combine that into one number under the square root by doing 100 plus 120 is 220. So now that we have all of this, we should realize that we just have to, simplify a little bit. But like I told you earlier, it looks like this is going to be irrational. We can't simplify this completely. Like, we're going to have to stop at some point. So just keep that in mind, right? We'll have to do 10 plus or minus the square root of 220. And as we saw earlier, the square root of 220, we can't pull out a 2, but we'll have to leave the 55 inside of there, as we did in that last example, right? So this is divided by 6, and then we would get our two different answers, right? We'd have to add that square root one time, and we put the word or, right, like always, and then we do 10 minus 2 times the square root of 55 divided by 6. Alright, so we could break this down maybe just a little more, because I see that we have some common factors in this case, right? This might not be everybody's favorite step, but we could factor out a 2 from this expression up top by pulling out the common factor of 2, right? Because this is 2 times 5, and this is 2 times the square root of 55. So they both have a 2. So that means I could factor that out. Okay, and the reason why I'm looking for a 2 is because I recognize that 6 is equal to 3 times 2. So I could write that as 2 times 3, and then because of that, I could factor out these 2's. So I would have my final answer that would look like both of these values, right? We'd have either 5 plus the square root of 55, or we'd have 5 minus the square root of 55 over 3. Okay, so either way it'd be over 3, and we see we just have the negative version of that. So we figured out that it does have intercepts. We found the intercepts, and so if we were to consider what the factored form of that equation would be, I mean, basically now we have an idea of what it's going to look like, you know, because we have specific numbers. So let's go back and look at that graph again, right? This is telling me that those places where it crosses the graph is going to be right there at those specific numbers, right? And it looks like these are approximations, right? If I was to look up the square root of 55, it's not necessarily just 805. So that tells me that if we zoom in, it might give us a more precise value. It might not. You could try to see if it will. It might not care. The calculator in this program might just stop at a certain point. And it looks like it doesn't, okay? But if we were to go calculate, let's say the square root, let's say we're going to look at this positive one, right? 4.139. Looking at our work, this would represent the 5 plus the square root of 55 times 3. So let's go to Google real quick and just calculate that in the calculator here. Let's do square root of 55. Okay, and we can see that the square root of 55 is 7.416, and it goes on for a long time. If I do the calculation that we had here, we had square root of 55 plus 5, and then we divide by 3. So if I add 5 here, I get this value, and then if I divide by 3, you can see that we get 4.13873282903. These numbers are going to go on forever. And we go look at the calculator here and look how it rounded it up to 4.139, right? So we can see that the graph on Desmos is giving us an approximate answer, right? It's not actually at 4.139. By doing our calculation, we see it's at 4.13873282903. It's going to keep going on forever because this number is irrational. So that means that, you know, it's going to keep going for forever, basically. We can't write it as a fraction. So this is a problem, right? Why would you want to factor something that can't really be factored with integers if that's the method that you're using? You got to watch out for that. And that's basically what the discriminant can help us do, right? Like we said, if we see when it's positive, we know that we're going to have two real solutions, and that tells us what our graph does. And, I mean, notice we only have to do a few calculations. We don't have to go plug in the XY chart and put all the coordinates in there and find the vertex and do all that. Just this little calculation of b squared minus 4ac tells us that we have two solutions. It doesn't tell us where they are, but it lets us know that we're going to have two real solutions if it's positive. If the discriminant is 0, again, it doesn't tell us where the solution is, but it tells us that we're going to have one real solution. And it does tell us the vertex will be on the x-axis. And the same thing for when it's negative, right? When we have a negative value, we can see that that means that the graph is not really going to even cross the x-axis at all. So let's go back to the worksheet that I gave you guys, because I think that was part of the problem today. I think we did examples like up to maybe number 3 in class. So we could do a few more examples and see what's happening, but just keep in mind, every time we go back, we can connect this idea to what's happening on the graph, right? We're going to figure out something about this graph without drawing it, okay? Let's just do this one calculation, and then you should be able to build up at least the intuition to tell me what's going to happen to it, right? So because we have a quadratic expression equal to 0, we can use the discriminant to find this out. So A would be 8, B would be -7, and in this case C would be 0, because again, look, we have a quadratic term, we have a linear term, and no constant term. So let's do b squared minus 4ac, change in all our blank parentheses, and then here we go. We're going to have b is equal to -7, a is equal to 8, and c is equal to 0. -7 squared gives us 49, and in this case, anything times 0 is 0. So 49 minus 0 is definitely equal to 49. And in this case, look, the discriminant, we get a value that is positive. And so this tells me that we're going to have two real solutions. All right, so I know before I even go draw this graph, that is going to cross the x-axis in two places. All right, as long as all my calculations are correct, yeah? It should cross the x-axis in two places. So let's go take a look. Let's go plug in this equation. I'm going to change the variable, of course, to x. So we're going to go graph 8x squared minus 7x. And let's go take a look and let's see where the x-intercepts would be. So we said we graph 8x squared plus, what was it? Minus 7x. Okay, so all that changed was the variable. And take a look, right? This crosses at these two numbers of 0, 0. And in this case, it looks like we get a fraction, 0.875, right? So if we were to look at that, that looks like that's 7/8. Okay, so this one definitely has intercepts. And this is what the discriminant tells us, right? It tells us something about the nature of the solutions. In this case, we know that this would be a rational solution. So let's go figure that out, because that's like the next little thing we have to learn about the discriminant is, are they going to be positive solutions? Are they going to be rational solutions or irrational solutions, right? So what was the value that we got? We got 49, right? We had our discriminant was 49. So now we can kind of rush through the formula a little bit because we already have that value. So we know that we would be able to use this formula. And like I said before, I know it could be a little confusing sometimes. In this case, our variable is b. So that's kind of my fault for not changing out that letter to be a different one. So, I mean, for the sake of the worksheet that we're doing, to stop you guys from getting confused, you could go ahead onto your worksheet and change these into x, but it really doesn't matter. You have to really kind of keep in mind that there's a difference between the b, that's the variable of this equation that we're looking at, and the b that's represented by the formula. Those are like different kinds of uses of the letter b. But in this case, we'll look at this value, right? So like we did, what's a equal to? A is equal to 8, b is equal to -7, and c is equal to 0. So we'll go apply the formula using these values. So we get all our blank parentheses and everything. And 2 times a, right? And so here's the thing. Because we got the discriminant already, we know this is going to be 49. And because all we have to do now is plug in our numbers, we have like kind of a shorter amount of work, right? B is equal to -7 and A is equal to 8, so we'll put that there. So now let's go figure out what we have in this case, right? We have -7, so that changes into +7. And the square root of 49 is equal to 7. And then on bottom we would have 16, right? So we can kind of see what happened here on the graph, right? We saw that one of our intercepts was going to be at 0. And think about that. I mean, we have two possibilities. Either we have 7 plus 7 over 16, or we have 7 minus 7 over 16. Okay? But 7 minus 7 is equal to 0, and 0 over 16 is equal to 0. So that's one of our x-intercepts right there, right? But in this case, we have 7 plus 7 over 16, which is equal to 14 over 16, and that could be reduced into 7/8. So we just figured out that we have a rational solution, right? We have real solutions, but importantly, they're also rational, right? So looking at what we did right now, none of this was necessarily necessary, right? We didn't have to do this by what the worksheet was saying. We didn't have to go fill it out through the whole formula. But I was trying to show you that, look, we got a square root that was a whole, like a perfect square, right? So because I knew that I could simplify this into something that would be a regular number, right, just like an integer, I know I'm not going to end up with some irreducible square root, like square root of 2, or square root of 3, or square root of 5, or square root of 55. None of those possibilities were going to happen in this case. because we have 49 and 49 is a perfect square. So when the discriminant is a perfect square, that tells us we're going to end up with a root, right, with a solution that's going to be rational. So that's one thing that you want to watch out for, right, is that we want to be able to tell whether or not our solutions are rational or irrational. And in some cases, that's going to mean that you have to know which numbers are prime and which ones are perfect squares. And obviously, as the numbers get bigger, that's up to you, right? You know your times tables, or you know that 19 times 19 is 361 before you just go reach for your calculator, right? So you got to think about these things. Again, we could do more examples on here. I suppose to help you guys out, I could kind of display the solutions to this assignment. And, don't cheat yourself, right? Don't don't just copy these answers. It's not going to be nothing, okay? What you actually have to do is know how to get them. So I'll put these up here so that you guys have a place to go look for the solutions, but you would have had to watch to the end of this video to get them, right? So we will notice that here it doesn't tell us whether or not they're all rational or irrational. And so for this assignment, I wasn't too worried about that, but I think when I go over these in class, I'll focus on that for sure. So, good luck working through this assignment. I think you guys have just a little bit of things left to learn before the semester final. So, just make sure you keep asking questions if you're stuck. Finish up this assignment and really try to follow all the steps of the process, all the little extra parentheses. If you mess one negative up in these problems, it's going to, kind of help you waste your time. So don't do that, right? All right, so I'll probably make a couple other videos to just review the rest of this assignment, but I made this assignment to kind of explain the discriminant in more detail for those of you that were kind of confused of why we're even doing this, all right? So good luck. All right, see you guys on Monday.